All right, everyone. So for today's lesson, we're going to be studying and learning about the properties of 3D solids, and we're also going to be learning about the volume of 3D solids. So do make sure that you take out your notes because this is going to be a big lesson today. We're going to be doing a lot of learning. And again, it's going to be up here. I'm highlighting in yellow, make it a little bit more visible with a red highlight. We're going to be learning about the properties of 3D shapes. And we're going to also go over what the 3D shapes, the different 3D shapes, or better said, 3D solids are. We can also say 3D figures. And so we're also going to be talking about how to solve for the volume of these 3D solids. Okay, so let's get right into it. And so what I want to go ahead and start with is what some of these figures are. And we all know that the 3D version of a circle is a sphere. So circles are in 2 dimensions and spheres are in 3 dimensions. Okay, and just to show that this is a sphere, I might add a little bit of shadow. Okay, so this is a sphere. Let's add a little shadow here. And it's not a perfect sphere, but pretend that I did create a perfect sphere. Perfect spheres don't exist so readily in nature. Planets are not perfect spheres. And so the next one we have is a cube. And a cube is the 3-dimensional version. It's the 3-dimensional version of a square. So in order to make it look like a cube, I'm going to go ahead and do the cube drawing. And this is the edge that is on the back that we can't see because the cube is a solid and therefore not always transparent unless it was made out of glass or something. Okay, then it would be translucent. And then the rectangle, we know how that looks, but I'd like to go ahead and show you the 3D version of a rectangle, and that's what called a rectangular prism. That's the 3D version of a 2-dimensional rectangle. And it's basically the same idea, and I didn't make it just how I wanted to make it, but that's okay. It's the same idea as the cube is for the square. And that's again rectangular. That's the part that cues you in on that it's the 3D version of a rectangle. Prism, this is the part that cues you in on the 3D piece. Okay, because prisms are in three-dimensional. I also want to go ahead and say that what makes all of this three-dimensional is it no longer is just length and width. There's also the element of depth now. Okay, so it's length and width, and also there's depth. So it's coming out at you with 3D, in 3D, in the way that a 3D movie sort of feels like it's coming out at you. This is exactly the same idea. So now we have a triangular prism, and I wonder if you can guess what I'm going to be saying about that. So go ahead and say it out loud to yourself or to yourself and see if you can guess what I'm going to be saying. So if you said that a triangular prism is a kind of um, uh, 3-dimensional version of a triangle, you are kind of right. What you could say is, and I'm going to redraw this, it's kind of like the rectangular prism, but instead of the faces here being rectangular, these two faces that we have here, they're, in the case of the triangular prism, they're triangular. Allow me to show you what I mean by that. So you have a triangle here, and that connects to another triangle. Let's see if I can pull this off in a way where it looks like something similar to what I want to draw. So it's a little hard to tell from that drawing, but what I basically did is I showed you that the faces on the sides are triangles. And this shape is not easy to draw in the beginning, you have to practice a little bit. It's a triangular prism. And that dotted line that I drew on the back there, that's exactly what it's supposed to be. It's supposed to be on the back. Next we have a cylinder. And a cylinder is basically kind of like a tube. Think of a tube. There's a lot of cylinders in our world. So you have like a circle and you connect that circle with two lines. That's how you draw it. And this is, this is a three-dimensional object. And so the part that's back here, unless this was translucent or transparent, you wouldn't be able to see this other piece of line that I did back here. This would be kind of dotted, okay? If that makes any sense. I know it's not always easy to tell by the drawings. A cone. So a cone is a fun one. We all know what a cone looks like because we have ice cream cones sometimes. Okay, so it's kind of like a circular or oval shape sometimes, and this is how you draw a cone, okay? And so that's a cone. Let's make it a little 3D here. Let's make a little bit of shade. And that cone can be upside down. It can be all kinds of things. You can have a dwarf wearing that kind of a hat, okay, like in a movie. And so those are some of the basic 3D solids. Let's go ahead and move forward with a little bit more. The first ones that we did here, those are all the three-dimensional solids that we're going to be talking about and using as examples. And the ones there's something called a square pyramid and a triangular pyramid. Now, I'm really getting into a lot here, but a square pyramid is basically a pyramid like the ones from Egypt, where the bottom is a square. Okay, and I try to draw that as a square. And let's see if I can pull this part off. And so the top, see how I'm making a pyramid? Now that's not a very, it's not what you call that's a slanted square pyramid because it's kind of off to a side a little bit. But that's my attempt at it. I think maybe I'll try drawing it again. Let's see if I can pull it off a little bit better if I try one more time. I think I might do it this time. You can draw with me and see if it works for you. So there you go. That's a better version of a square pyramid. And remember, it's a square because, let's zoom in a little bit, the bottom, the base of that pyramid, this is the important part. It should be a square. Okay, and if I would have drawn it a little bit better, you would have seen that it was more of a square. And in the case of the first one that I tried, my first attempt, which wasn't great, this part here, the base of the pyramid, the bottom of that pyramid is a square. In the case of a triangular pyramid, can you guess how it's going to look? So go ahead and think it out loud, or you can pause the video and then think it out. If you said that in a triangular pyramid, if you said to yourself that it's going to have a base that's a triangle, if you got to that point, you're actually correct. So the bottom is a triangle and the top is, it's just a pyramid with a base that lies flat. That's what I mean by the base. It's a triangle. This is called a triangular pyramid. Triangular pyramids exist in the real world. People have built them, and also square pyramids have been built. They're both very good, stable structures. They're very stable. The pyramid is an extremely stable structure, and that's why it's been used historically. The ancient peoples of our history, just because they're ancient does not mean that they were not intelligent. Okay, they paved the way for us, for our modern society. And this is one way they did it. We still use pyramids for structure. So I'm just trying to draw it a different way to see if I can capture a little bit better, but you get it. And in the background, we have this. This is Again, if it was made of glass, you would be able to see it, but in a normal circumstance, you wouldn't be. That stuff is on the background. And the base of this pyramid is this triangle that's here, just like the other example that I made. So you should be drawing these along with me as you're following along because it really helps to solidify. It's also fun. Okay, so those are basically the figure page as well with the pyramids. So let's talk a little bit more about the properties of these figures. So the properties, the three-dimensional properties of three-dimensional figures. This is important, and I'm going to be talking about three properties right off the bat. Just to state them, I'm going to be talking about what a face is on a three-dimensional figure. I'm going to be talking about what an edge is on a three-dimensional figure. I'm also going to be talking about what a vertex is. And we're going to be writing these terms down. I just wanted to state that. If you already know what any of these are, whether you know what a face is on a three-dimensional figure, or what faces are, because three-dimensional figures have more than one face. A two-dimensional square has one face, for example. Then if you know that you're off to a great start, we're going to talk about what an edge is, and then what the vertex is. The vertex is like the pointy parts. Okay, the edge are like basically the lines that you see that make up a square. Okay, that's what the edge is, but we're going to get a little bit more into it. First off is face. A face is a two-dimensional shape that makes up one surface of a three-dimensional shape or figure. So in the case of this shape that we have here, this figure or solid, can anybody guess? Can you guess what the name of that figure is? So if you said that that was a rectangular prism, you would be correct. Now the face on this rectangular prism, there's many of them. One of them is here. Let me get a strong color for that. One of them is here in the front. That's one face. Okay, so think of this figure that I'm looking at here. Think of it as, think of the entire, what I'm coloring in is like a rectangle. So that rectangle is one face of this rectangular prism. Okay, and another face is in the back here. This is another rectangle that makes up another face in this rectangular prism. So as I'm coloring in, can you go ahead and guess how many faces this rectangular prism has? When I get to the end, you should give me an answer, or give yourself an answer. Okay, if you guessed that there are, let's see, 1, 2, 3 if this you count this side, 4 if you count, and I said side, I shouldn't have said that, face, okay? 4 if you count that face. The bottom base is a face, that's 5. And the top here, we haven't counted that, that's 6. This figure has 6 faces, okay? So if you said 6 faces, you're on the right track. Okay, so what I want you to try now yourself is see if you can do the same thing with this figure. Oops, with this figure. Let me make them bigger. So I want you to do two things yourself. I want you to think to yourself, okay, what kind of figure is that? What sort of solid? That's the first thing. So you have to name what kind of solid that is and then how many faces it has. So solid type or category. So name it without looking at your previous notes if possible. And then secondly, how many faces? Okay, so see if you can answer those questions, and you can pause the video now. Okay, so coming back, hopefully you knew that that was a what kind of a figure is that? If you said it's a triangular pyramid, you're on the right track. So you should have said triangular pyramid. Let me make this more spacious. Now the faces, let's go ahead and do that one together. So there's a face, and I'll zoom in to make the coloring a little bit easier. There's one face that makes up the base, and that's down here. So that's one face right there, and I don't think I'm going to necessarily color them all. Or maybe I should, just for this one example. There's one face there. There's another face that makes up this part here. And remember, what I'm coloring in here these are all two-dimensional triangles that are making up this three-dimensional triangular pyramid. It's one face there. Let's try and make the coloring so it's the dot, so it's a little bit thicker. Let me see if this helps with the coloring. Yeah, helps. Okay, so we have two. Let's pick a different color. Let's make it blue this time. And we have on all the way on the back. Now it's hard to see this, but on the back we have another one. We have another face, and that's what makes it hard. If you can even say that this is a hard problem, some of you are thinking it's not a hard problem. So the back is another face. It's a big face too, because of the perspective that this triangular prism has, the orientation. Okay, so we're on 3 now. And you can color with me if you'd like. You can shade in. It's nice to take your time sometimes in this world. And last but not least, we have this side here. I said side again. I shouldn't say that. This face. I just want you all to get confused. If you already knew all this really well, then it would be fine. So this is another face. And notice that it goes all the way down. Okay, it's not going to be a perfect coloring, but I'm giving you a really good idea, and it's good to let it sink in a little bit. Okay, so those are all the faces that it actually has. It has the one on the bottom. Okay, so there was one here, there was one here, there was the one in the back, that was 3, and then the fourth one is the last one I did. So that was 1, 2, 3, 4 faces. So hopefully you got that right. That's 4. Okay, so far so great. So we're going to be moving on to what an edge is. And here's a different 3D solid for you. That's a rectangular prism. And so the edges are easy. The edges are the lines. And so one way you can define it as an edge is where two faces meet. So allow me to show you exactly what I mean by that. And let's find two faces. So I'm going to go ahead and I'm going to use the face from the back, and I'm going to make this a little bit bigger. So there's one face back here. Okay, and make sure that you're doing this with me because it really makes it so that it sinks in really well. You don't want to forget this for 6th grade for sure, or for 7th or for 8th. In geometry, you'll be doing this as well. But you won't be covering this, you'll be moving on after this. So you want to have it well memorized. That's one face. And let's use yellow. Let's see if yellow stands out here. Not that much. What about purple? Much better. So here's another face to this figure. And what I want you to see, I'm going to try and do it as quickly as I can, is that those faces are going to meet on an edge. And that's how you know that it's an edge, because the faces meet there. Okay, so hopefully you know what edge I'm talking about. Okay, and if your mind plays tricks on you and it switches away the perspective, that's perfectly normal, okay, because 3D shapes do that to our brain. But here's the edge that I'm talking about. I'm making it really sort of like a dark red. That's one edge. How many edges does this figure have? Can you count them? So we just said that that was one edge. Here's another edge. I'm doing it in blue. Okay. Another edge is here. We should probably keep count, right? So we counted this one in red, 2, 3, 4. You don't want to rush when you do this, okay? Because when you are doing your exercises, if you get one wrong, you go back. So that's 5, 6, 7, 8, 9, 10, 11, 12. On my count, we have 12 faces. I'm going to do them again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 faces here. Oops, did I say faces? 12 edges. 12 edges, go back. Okay. 12 edges. Come on, Mr. C. All right. So those are edges. Hopefully you didn't get too confused there. And now the last one is vertices, or a vertex. The plural version of vertex is vertices. A vertex is the point. Now I'd like to really focus on point or corner, okay, because that's how I think of it. So it's the corner of a 3D shape where 2 or more edges meet. So if you look at the edges, now you know what edges are, right? They're the lines. Okay, so you have an edge here, and you have an edge here. These are the lines, right? Where do these edges meet? Here. So this is a vertex because the edges of those lines, they meet there. It's also a point. Not a point like a little point like this, like a corner, okay? A corner is probably the best way of describing. Here's another corner. Here's another corner. And here's another corner down here. Okay, and there's not really a corner here. It looks like there might be, but there's not really a corner there. That's actually like a straight, just an edge. Okay, so this particular solid, which is a triangular pyramid, has 1, 2, 3, so it has 4 vertices. There are 4 vertices. Notice that I use the plural form there. Okay, so we did vertices, and that was fun. Now, let's talk a little bit about this idea of volume, okay? The volume is sort of like, well, let's start from the beginning with volume. I think that's probably the best thing we can do. The formula for volume. For volume is length times width. Remember length times width? Yeah, we studied that before. So volume, or V, is equal to length times width times depth. So what's going on here? Why did I just add that? Do you remember when we were studying squares that I said that a square has a length, and the length you can also say it's not just a length, you can also say or a base. Remember how I said that we were going to start talking about it as bases, but now we're going back to length because it doesn't really matter, but it's a little bit easier to look at, okay? And I also said that a square, because it's two dimensions, has a width. And I said you can think of it as a width, or you can also say height. But for right now, like I said, let's focus on it as length and width. Well, what we have here isn't a square. It's a 3D version of a square, which is a cube. And this cube has length and width. Watch, let me show you. Here's your length. And the width, or the height, it's the same thing. It's going to be here. Let's do it on this side. It's also on this side, by the way, but I'm doing it on the other side. So that's the width. It's called width instead of height, just for simplicity. But it also has a third dimension, you all. This is the first dimension. This is the second dimension. Okay, remember how area is always to the second power because there's two dimensions, like I just did? Okay, but now look at this one. It's coming out at you here and here, like a 3D movie does. So just focus on one of those. Just focus on this one. That's the depth. 3D things are called 3D because there's three dimensions. Proper spelling there, Mr. C. Dimensions. Those dimensions are length times width times depth. And again, you can call it length, you can call it base, you can call it width, or you can call it height, but this is depth for sure. Okay, so no confusion there. That's why the formula for solving for the volume is length times width times depth. But there's more. Let's get into this definition. The volume of a shape, okay? The volume of a shape is the space that 3D solid contains inside. It's a little bit like the area of a square, but because it's three dimensions, we're measuring the space taken up in the inside. Let me get a little bit more into it. If you were to take this cube that you see here, and you were to fill it with water, that water would take up, if you fill it entirely, it would take up all the space inside this cube. Let's make it really look like water. You fill it with water, pretend that red stuff is water. And it's filling it out here, and then it begins to rise, right? And eventually it'll fill up the entire cube. Pretend, okay? What's happening there is you just accounted for all the volume of that cube, which is the space inside. Now, volume can be a little tricky. You know, some scientists prefer to think of it a little bit different. They can say that it's the space that a 3D solid contains inside, or you can say the space that this 3D solid takes up in the real world. That's another way of thinking about it. It's like, are you going to see it from a glass half full perspective or a glass half empty perspective? It's the same thing. It's just a different way of looking at it. The unit used for the volume, so the unit we use for volume is the cubic meter. So it's going to be meter to the third power this time, okay? And it's not going to be something else, or it's not going to be something to the second power. It's now to the third power, and we call that either meters cubed or cubic meter. So that was a pretty big explanation. And I think that one of the best ways of doing this problem is, or moving forward with this idea, is actually doing an actual problem. This is a rectangular prism. It has 3 dimensions. The dimension here, its length, L equals, let's say 10 meters. The dimension that is the width or height is going to be, let's make that 6. Let's make that 6 meters. And the dimension that is, now I probably should have done something a little bit different. Let's go ahead and go back for a second. I want to help you understand a little bit better, so maybe I should have gone with this with the length, just for the sake of example. It doesn't really matter. And let's say that that's 8 meters. Okay, so the length is 8 meters, the width is 6 meters, the depth is this part. Pretend. This might be easier to look at. And so D is going to be, let's make it 10 meters. Now, having said that, remember that the formula for the volume of a cube or a rectangular prism is going to be length times the width times the depth. Can you solve for the volume? So let's make volume equal V. The length is here. That's 8 meters. So I'm going to put it in its parentheses. The width is here, and that's 6 meters. And now the depth is here. How deep it is, how much it comes out, okay? And that's 10 meters. Let's go ahead and start by multiplying these two numbers together. And so let's keep V equals 8 times 6 is 48. And then meters times meters is meters squared, right? Or square meters. Times, what do we have left? Well, we did these two. We have 10 meters left. So multiply 48 times 10. And that's going to be 480. And then meters squared times meters, well, think about it, that's meters squared to the second power times another meters. That's going to be meters to the third power. So meters to the third power. And what that means is, and the way of saying it is, we have 480 cubic meters. Okay, so V equals 480 cubic meters. That's your answer for that. Okay, so far so great. This is one you're going to do entirely yourself. Solve for the volume. And you do have to memorize the formula for the volume, okay? Which is length times width times depth. Ready, set, solve. Okay, so hopefully you start solving this problem, and hopefully you solved it. And so it's going to be V is equal to L, let's use the little advanced time symbol, times W, width times D. Let's plug in the values. How long it is, it could be anything, right? So let's use this one for length. It doesn't really matter. You can use any of them for length. So let's use 8 feet for length. That's the length. So I'm going to say how long it is, 8 feet. How wide it is, let's say this one could be the width, 7 feet. How deep it is, let's use that for how deep it is for depth. That's one foot deep. Okay, therefore V is equal to 8 times 7 is 56. Feet times feet is feet squared or square feet times. We did this, we did this. Now you're going to take 56 times 1 times 1 foot, right? So 56 times 1 is 56. Easy. But feet squared times 1 foot, that's going to be feet to the third power, or cubed. So you should have gotten this for an answer. And if you did, congratulations. Give yourself a pat on the shoulder. Excellent job. Okay, so moving on, this is going to be your assignment for IXL. It's DD2. And hopefully you're still watching this video because I'm going to tell you the other important piece to this. I'm changing the rules a little bit. I'm giving you a new minimum requirement to help you with workload. So do at least 10 minutes. Okay, at least 10 minutes or up to 100% of the assignment. And that means 10 minutes for this one, but then also 10 minutes for this one. So here's a sign, less than or equal to. Oh, sorry, that didn't mean less than. I meant greater than. Greater than or equal to 10 minutes. So you can do 10 minutes, but no less than that, okay? Or all the way up to 100%. And if you want to do that assignment over and over and over again, 100%, 200, 300%, go for it, okay? But I want at least 10 minutes of each. It's going to be 20 minutes. Okay, you all. So that's all. Good luck and good logic.